All right. Okay. So let's get started with the linked list. So how many of you know about linked list? Only a few. Linked list. Okay. So most of you didn't know about it, right? I assume. Okay. So first, before we start coding it, so let's talk a little bit about it. So linked lists are made up of nodes, and each node contains a reference to the next node, and also it contains a unit of data. So it has two attributes. One is the data that it contains, and the other one is more like you can think it more like a pointer that it points to another node. So just as a quick example, let's say here it says that create a node class that automatically initializes its own data and next, and also prints the value of the data. And the default values are none. So for this, I actually want you to also implement at the same time as me, so you can go through the thought process. Okay, so let's all generate this node class. It's going to be, so everybody is ready with the IPython notebook or PyCharm, whatever you want to use? You are ready, right? All right, so let's start. I always put this object. You don't need to use it if you are using Python 3, but I think it's a good habit anyway. Okay, so it needs to start the class automatically. It initializes the class automatically. So here we need to have init function, right? With double underscores. And so let's give it a name for the value. Let's say it takes a value, or you can say data too, and then it says initialize its own data and next. So here I'm gonna call this self. Let's say data equals value. And for the next node, it's pointing. So let's start with none, because we don't know what it is going to point yet. So we just created this simple class node. Actually, maybe we can also add, since it says it initializes its own data and next. So maybe we can also say maybe next node here. And let's assign none to both of these. Maybe for this one I can change it to next node. Okay, so it is automatically none unless we tell it what it is going to point to. And the value is also none. And it says one more thing. So it prints the value of data. So we want the print function to work in a way that when we say print node, it should just print the data of this class. Do you remember how I overwrite print function? String, right? With double underscores, like we did last week. And for this, does it need to have any other arguments for print? No, right? And should I say print or return? Return, yes. And let's say string here, self.data. All right. Okay, so now let's let's test this. So let's say node is node test. So the data is test, and let's say print node. Okay, so it works. All right. So now, given that we have this class node, it says create instances node 1, node 2, and node 3 from node class with data values 1, 2, 3 respectively. So what we need to do is we just need to say node 1 using our class node, and the value is 1. And we are going to have another node 2, again using the class node 2, and node 3 we have class node 3. Okay, but here, if you have noticed, I didn't connect them yet. They are not linked yet. They are just independent nodes so far. So how it looks like is exactly like this. So we created node 1 with data value 1, and next is none. So it does. So next doesn't point any other node yet. And we created another node called node 2, where data is 2, and next is again none. Doesn't point to anywhere yet. And node 3, data is 3, and next is still none. Okay, so now we want to link these nodes such that node 1 points to node 2, and node 2 points to node 3. So we are kind of linking all these nodes, these 3 nodes, right? So do you guys want to type it, or tell me how to do it? Okay, continue.
Done next. And then equals 2.
Right. And
just do the same thing for 2 and 3.
yes. So node 1 next points to node 2, node 2 next points to node 3. What about node 3? Should I do anything for that? It's okay that it points to none, right? It's like the end of the linked list. Okay, so I linked them. So yeah, the reference of the third node is none, which indicates that it's end of the list. So now we have something different than this. So first they were all independent nodes. Now we connected them. So now actually we have this. So node 1 next points to node 2, and node 2 next points to node 3, and node 3 next points to none. Okay, so this is actually what we call by linked list. All right, so everybody follows me up to here? You guys are also coding this? Okay, good. All right, so next, write a function print list that takes the head of the list as an argument and prints each node until it gets to the end. So I'm going to give you some time to think on about this, or maybe implement it. So anybody wants to do this for me?
Just put every node in a list, then put everyone in a list, then put. So
Put everyone in a list.
Yeah, then put the list. So it will.
Okay, so let's start from the basics. So first define the function, right? And so the input is what? Anything? What do you want to call it?
Head.
Head, okay. Okay, then what? Hmm?
Create a list.
Create a list. Why are you creating a list? I already have this. This is already a linked list.
Okay,
Hmm? Create a loop. For loop, but you don't know the while, okay. While. What's the condition?
There.
head on next, not equal to now.
Why necessarily next? What about there is only one node?
You should always print ahead.
What about just head? Right? I mean, there might be a value, the next might be none, but you still want to print it. Okay. And now you say print here. Okay, I can just say print head, right? And so I don't need to say head.value because head is a node and it's a class. And for that, I already defined print function for itself. So I can just say print head. And what?
Head equals to head.
Mm-hmm. Okay. Okay. So let's say I want to test this.
But I think you say it starts from the tail. Does that mean from the last one to the first one? For this one, I think it's from the first one to the last one.
Yeah, I want it from first to last. We are gonna do backward too. So let's say this is forward, starts from the beginning. So you want to test this? Print list. So instead of head, I can actually, so my head is node 1 here, right? That I already created. Everything is linked to each other. So do you think I can say node 1 only? Do you think it should work? Any objections? Okay. All right, not bad, but I don't like it. It prints this way. I want it to be horizontal. So do you remember how to make it horizontal with print? And, right? Yeah. Good. And here, let's put a space. So let's redefine this. Okay, good. So we are able to print any linked list when you give the head. All you need to do is give the head of your linked list, which was node 1 here, and then it keeps calling each node until you hit the end by saying while head. This is actually, you can either say this or while not head none. So this is more verbose, if you prefer. Okay. All right. So now write a function print backward that prints the list backward. So in other words, that starts from the tail, like what you were thinking before. So I want to give you some time to think about this too, but let me just do the basics. Print backward. Let's say I give you head. Any ideas for this? Can't think like recursion. First of all, if not head, return nothing. Okay, since it's going to be recursion, I need to have some base case. So if you hit none, just return nothing or stop this function. Actually, I don't want to call this head. I want to call it linked list. So let me define this. Let's say head is linked list. So it is more like to tell myself that linked list has a head. And also, let's define tail as head.next. And here, you think I can use recursion? I can call the function itself. Any ideas here? Mm-hmm.
While tail.
While tail? Okay. I mean, so let's say I want you to use recursion. Let's say you.
Yeah, I will. So, I mean, if the next is not now, I will use this function. We will recursive print backward now. I will say print backward tail.
Okay.
The input will be tail.
Okay. So why not? Why do you need to while again? Why not just say backward?
Yeah. Because I think I need a return at the end. When I found the last one, I need to print the val of this one. So.
Okay, so for that you don't necessarily need to call the function itself. So you're actually changing recursion with while loop. But for this, we can actually, for tail, we can call the function itself again. And now, but at some point, we need to print the head, right?
Yeah.
And again, let's say I want to do it horizontally again. I'm going to put this and here. Okay, so let's see what it is doing. So it takes the linked list, and it assigns head and tail to that linked list. And then it calls the function itself again on tail. And now for that tail will become head, and tail.next will become the second next tail. And until it hits the none value, and then it starts printing the head. So think it like a stack of operations. Okay. So let's test this with our node 1. So remember, node 1 is the head of the linked list. And then when I say print backward, it should print 3, 2, and 1, right? So let's see if it is going to work. Okay. It worked. So is this clear, everyone? What I did here?
Actually, can you explain it again?
Okay, so this is clear, right? If it is none, if it is empty, don't return anything. So this is our base condition for the recursion. So this head it's actually for me to say that okay, so I want to know the head of the head of the linked list. And then I define a tail, which is like next of that. And I call the same function for the tail. And this is going to be printed later. So let's say it was 1, 2, 3, right? Before printing 1, I call for 2 and 3.
Okay, so it kind of goes all the way in first.
Yes.
To get the right order, and then it works its way out.
Yes, exactly. So again, so 1, 2, 3, let's say. The first one is 1, second is 2, third is 3. So before printing 1, I call this for 2, 3. And then before printing 2, I call this for 3. And then for 3, tail is going to be none. So the head of 3 is just 3. And then it remembers it was supposed to call 2, 2. And then it was supposed to call 1. So it goes from like 3 to 1. Okay?
That makes sense.
So the print backward function is putting the tail to the head.
Putting tail to the head?
Yeah. So what is the recursion to make this? Is it putting the tail in the head? Like,
No, it doesn't modify anything. It just takes the rest of the linked list. Every time you start with your linked list, and then you skip head, you go to the rest, and you skip the head of that sub-linked list, and you go to the next one. And then once you hit the end, you remember to print what you were supposed to print, and then it starts performing all those print operations that we skipped. Okay. All right. So there's something we need to be careful when we do this. So if you have this infinite list like this, let's say we have node 1 that points to node 2, but node 2 actually points to itself. So when we say print for this linked list, it's going to take forever. You know, so this is I'm just giving this as an example to make you aware of there might be some edge cases when you write these kinds of functions. So always think like, okay, is there an infinite loop when I write this recursion or while loop? Is there any chance that it might go forever? You know, so this is just one case that those print functions will not work. We're not gonna now do how to do for those, but just to make you aware of these situations. Okay, so now write a function remove second that removes the second node in the list and returns a reference to the removed node. So remove second. Of course, I'm going to assume, let's say, the linked list already has the second node. So any ideas for this?
So we're assuming that it has the nodes, so should we check first?
Yes, so that's a good practice to check. But let's say everything is ideal first. Actually, you can say if not linked list.
So it's head.next equal to head.next.next.
Okay, so linked list dot next equals to link. Okay, but we also want to return the second one.
Yeah, we just keep the value then to this.
Okay. Okay. So let's call them like first, second. So first is linked list. Second is first dot next. And we want to do, maybe should we do
Second equal to first dot next one.
No,
So
no.
we need to pick the
Uh,
value first.
right, so first dot next equals to second dot next. And for second, should we do something with second dot next? Because we want to return it. Just return, but shouldn't we make it none first? Okay, so the first is the head of the linked list. Second is the next one. And then by making first dot next is second dot next. So the second dot next is actually the third node. And we make sure that the first one points to the third one. And for the second dot next, we actually separate it from our linked list by assigning none to the next. And we return second. Okay, so let's test this. Second equals remove second. So we had node 1 as a linked list already. And then let's say print second. And I also want to use our print list function that we wrote here. So what happens to my node 1? Or maybe I should also print it before, so you know. I'm going to say print linked list before modification, and then here I'm going to say remove node, and here we can say print linked list after modification. Okay, let's see. Oops. Right. Right, let's create this. Oh, anyway, so yeah, I think it's still clear. I mean, I wanted to have a line here, but I don't want to change it because we already modified it. So the linked list before modification was 1, 2, 3, and the removed node is 2, and linked list after modification is 1, 3. So I just modified it in place, basically. What really happened here is actually like this. So it used to be, so node 1 was pointing to node 2, node 2 was pointing to node 3. So I actually removed these edges from here. I basically made node 1 point to node 3 directly by this line here. First dot next equals second dot next. So first dot next and second dot next is this. So I created this link. Okay? Is it clear, everyone?
Can you scroll up to your function? The second, number second thing.
First dot next equals second dot next.
Yeah.
So first dot next points, so second dot next is this. right? And then I'm just creating this link between first and third by that line. Okay? Yes, basically, yeah. But it is in place. I didn't create a new linked list. Okay. And I also got rid of this second node. Actually, now next points to none. Okay. So write a function, print backward nicely, that prints a list in the format of this. So basically everything the same, but just add a brackets around what you are printing. So this is pretty simple, but there's a reason why I'm giving this. So let's say linked list. So basically just putting brackets makes it nicer. That's the assumption. So any idea here?
Just change the print line instead of putting the list in the.
But we want to add the brackets, right?
Yeah.
Yeah. So let's add the brackets. And again, I'm gonna make this and as like, so it's all horizontal. And I can call my print list function for linked list and print, now close the bracket and say and equals this. So let's test this.
It's not backward. The print list.
Oh, sorry. Thank you. Yes, it should be print backwards, right? Okay, thanks. So I'm gonna have this node 1. So what should that print? Remember, we removed the second one, so we have only 1, 3. 3, 1 with the brackets, right? Okay. Ooh. Why?
Did you rename it? Since you made it.
Yes, thanks. Okay, so this is very simple example, but I wanted to introduce these terms as a wrapper and helper in programming. So basically here print backward nicely. It acts out like a wrapper, and the print backward function is actually a helper. So we define a wrapper function where the wrapper function for print backward basically. So you get used to with these terms. All right. Okay, so now we are going to create a linked list class. Do you have a question? Okay, so here it says create a linked list class whose attributes are length of the linked list and a reference to the first node. So I'm gonna call this linked list, set object, and we are going to have a init function. It doesn't say what arguments it should take, so I'm going to just assume self.head so self.head is none, self.length is 0. because it only says the attributes are length and also the head of the linked list, but doesn't say they should be arguments. So I defined this new class, and now before implementing methods for this linked list, let's go back to the node class. So it says make print backward a method of the node class. So let's go to node class. Okay, and now I want to say print backward self. It doesn't need to take any arguments. Okay. So same thing. But this time you can say if self next is not none. You can define tail as self dot next, and you can say, so tail is going to be a node too, so you can say tail dot print backward, and print print self dot data. Yes. You can say self dot data or just have to same thing basically. Can still make it. And okay, so let's see if this recursion also works. So look at the next of the node. If it is not none, define a tail, and for that tail, so it's going to be node 2, so I just say tail dot print backward, and I keep going on, and then finally I print the self dot data, and I add this and to make it horizontal. All right. So maybe we should test this. Let's say node 1, node 2, node 3, all like node 1, node 2, node 3, and I make node 1 dot next is node 2, and node 2 dot next is node 3. And so let's now say node 1 dot print backward. Let's see. Okay, it works. So same logic as a recursive function we defined, like print backward. We made this a method to the node class, and then as long as next is not none, we define tail, and then we call the function itself for that tail, and once we finish this, we print the data of the node itself. And here is the test. for what we wrote here. Okay? So same idea, I just made it a method. Okay, so now define a method, print backward of linked list class that adds brackets around the values. So now we go to the linked list class that we just defined. So now we want to have a method of print backward against self, and so we want to put brackets. That's easy. We just have print brackets and this. Okay, so here, what do you think we should have here? Remember, we just defined print backward for a node, and head is a node too, actually. Any ideas? Exactly, yes. Self.head. So this is a node, and then I say print backward. And then I put the other parentheses here. Okay. So let's test this. Well, it's a little bit hard to test because. Okay, maybe we can do this. So let's call this linked list. Linked list. And then I'm gonna modify the attribute of head. I'm gonna change it with node 1 that we had. And then if I say linked list dot print backward, it should print 3, 2, 1, right? Okay, it works.
But if we just write as the length is still 0.
Yes, so this was just to, very good observation, this was just to test if my print backward function works. Of course, so we have this node 1, which has 3 values. Self length should have been 3 too. But we are gonna modify it by defining a method at first. But now I really just wanted to test this. Okay. All right. So now define a method at first that takes a value. Yes. Oh, wait, you're right. It shouldn't put the brackets, right? Oh, okay. No, yes, okay, here. All right. Because before, when I made linked list equals node 1, I just made the instance of a class node, and for the node class, we don't have these brackets. That's why it didn't put the brackets. But now I called this print backward function on linked list, and here I just changed the attribute head of this linked list by making it equal to node 1. So before, this was wrong because this was, I mean, not wrong, but here the object type was node when I have this line here. It should have been like this, and now it puts brackets, right? Now define a method at first that takes value of a data as an argument and puts it at the beginning of the list. So we are going to have this linked list, and then let's say at first. So it takes a value here, and we want to put it to the beginning of the list. So any ideas with this? Huh? Sorry, I cannot hear you. Well, you need to create a node with this value and put it at the beginning of your list. Yes, first create a node, value, and so now node.next is none. So we want to make it what? So we are putting this to the beginning of the head, right? Node.next should be self.head. And what else? Equal to yes. And what else? We have this length attribute. Right. All right, so let's test this again. Linked list. It should be a class of linked list. And let's say linked list at first one. And 2, 3, let's make it a little bit different, so make it 4. And let's also print it backwards. So it should print in brackets 4, 3, 2, 1, right? And we should also print maybe start a new line. Length of the linked list is linked list dot length, which should be 4. Let's see if it works. Alright, perfect. Oh, why is it 1, 2, 3, 4? Oh, do you understand why it is 1, 2, 3, 4? Yes. Yes. So I first put, so basically this is a linked list of 4, 3, 2, 1. When I said print backwards, it prints 1, 2, 3, 4. And we also managed to increase the length, which is supposed to be 4 anyway. Okay? Any questions so far? No? Is it too easy? No? Too hard? Yes? All right. Okay, so let's a different data structure called stacks. So similar to linked list. So stack is a collection. So in other words, it's a data structure that contains multiple elements. So it is also sometimes called last in, first out. So you can't think. I always think stacks as more like a plates. You know, you put plates on top of each other, and whichever plate you put the last, you take it first. So that's why it is last in, first out, because the last item added is the first to be removed. So here is a display of it. So let's say we have these stacks of each item. So we push everything here, but we also pop from here, more like plates. And this is the top of the stack. Okay? So implement a stack class that uses a Python list and initializes an empty items attribute. So we are going to have this class stack. I put object anyway. And I initialize this.
I have a question. Because we will use the linked list to make a state, right? So can we instead of the object to linked list, make the linked list?
Yes, you can do that. But it was. So now I want to show different things, so they are not necessarily have to be related. But of course, you can inherit if you think it's useful. All right, so we say self, and that uses a Python list and initializes an empty items attribute. So I just say items, and it's empty. That's it. That's what it is asking. Yes. And now define a method push of class stack that adds an item to the stack, and the method takes item as an argument. So I just take all this stack class and I say push self, and let's say it takes item because the method takes item as an argument, it says, and I want to push this to my list. What should that be? Right. Okay. I'm not going to test this because these are pretty trivial. And so we have push, and we also want pop. So remember, so we push and pop from the same place. So define a method, pop of class stack, that removes an item from the stack and returns the popped item. So I'm going to take all this, and now I will define pop self. Do I need any other arguments here? No, right? And I say self.items pop, right? Like this. Right. Yes. Yes, we return it to. All right. So define a method is empty of class stack that returns true if the stack is empty. So this should be very easy to. Is empty self. Okay, any ideas? right? Or you could also have done like if self items equals to this. You could do that too. Okay, so we have a stack class. So now demonstrate a usage of stack. So add items 54, 45 plus and remove all items until the stack is empty. Okay, so let's call this S and start a stack class. And so we are going to add these items. What should I say? Push 54 and S dot push 45 push. So let's make this one a string. And now remove all items until the stack is empty. So any ideas how to do this? We just defined is empty function. Somebody said while. Oh, yes. And I want to print this too. Okay, so we added 54, 45 plus, and then we removed plus first, and 45 later, and 54 last, because this is a last in first out data structure. Okay. All right, so let's talk about how to use stacks to evaluate postfix. So what do I mean? So in most programming languages, the mathematical expressions are written with the operator between two operands, like 1 and 2 are operands, plus is an operator. So this format is called infix. So an alternative use by some calculators is called postfix. So in postfix, the operator follows the operand. So for example, we have 1, 2 plus. So here operator is plus. So it follows these two operands, which are 1 and 2. So the reason postfix is sometimes useful is that there is a natural way to evaluate postfix expression using a stack. So starting at the beginning of the expression, get one item at a time, right? And if the item is an operand, we push it to the stack. And if the term is an operator, we pop those two operands off the stack, perform the operation on them, and then push the result back to the stack. And then when you get to the end of the expression, there should be exactly one operand left on the stack. And the operand is the result, basically. Okay, so maybe... Okay, so before coding this, let's have some example. So let's say 1, 2 plus 3 this. So let's say we start iterating through all these items here. So first the value is 1, right? So I'm gonna create a stack. So this, I'm not coding, this is just to illustrate how stacks can be used to evaluate these postfix strings, okay? So since the value is 1, since it's an operand, I push it to my stack, say 1, and do nothing. So next one, in the next iteration, value is 2. And now I also push it to my stack. Okay. And next one, the value is what? Plus. So it's not an operand, it's an operator. Then I say item 1, stack pop, which is going to be, let's say, 2. And this is really like a pseudocode, so don't worry about the syntax, but try to get the idea. And then item 2, I'm gonna say stack.pop again. It's gonna be 1. And we are gonna perform an operation of plus on this. So item 1 plus item 2. And by the way, so here my stack is empty, right? Because I popped 2 items. And I perform this summation operation on item 1 and item 2. And I push it back to my stack. So now it is, well, so this value is going to be 3, right? So now in my stack I have 3. Okay? Now I have this in my stack, and so next is 3. So I continue iterating over my items. So now value is 3. So since value is 3, since it's not an operator, I actually append it to my stack, which was 3 first, and I add 1 more 3. And after 3, what I have is star, which is multiplication. So value is star. And now, since it's an operator, I'm gonna say item 1 stack pop, which is going to be 3, and item 2 stack pop, which is going to be again 3. And now my stack is what? Empty. And I'm going to define result item 1 times item 2, and I'm going to add this to my stack. So this value is going to be 9 here. So my stack is going to have 9. And finally, after iterating through all the items in my string, I'm going to say return, actually result is 9. Okay, so this is the algorithm we want to apply to evaluate these postfix strings. Okay, so was this clear what we did here? Everybody? Okay. I hope it will be more clear when we write the function. So write a function eval postfix that takes a string with space as a delimiter and evaluates the value of postfix. So let's assume we have only 2 operators, star and plus. Okay. So let's say start this. So it should take the value of the string. Let's see what. Yeah, we can say expression actually. But so this is a string with delimiters of space. So you want to make the list first, right? Because you want to iterate through each item. So let's say tokens x dot split, and assume they are always separated by a space. And what else should I do here before starting my for loop? Right. So let's call it stack. Okay. And now I can start iterating through these tokens, right? Tokens. Okay, so if okay, okay, we can start with plus or star, and if it is not plus or star, it's always number. Let's assume that. So we can say, okay. Prof.
We need to take this member, so here's the name.
Okay.
Number 1.
Number 1, you see?
Number 2.
Let's call it result. And what do I do with the result? Yes. Okay. So let's say Elif can basically just copy all this, right? Put a star here. As
step up to push token.
Okay. And what should I return? Stack.pop, yes. Okay. So is this clear what we did?
If the input don't follow our loop.
Yes, yes, yes. So I mean, of course, you should put some test cases. You know, make sure that it works for each case. But now I'm trying to give you the general idea. Okay. Otherwise, we can't finish anything here. Okay. So, oops. All right. Okay, so now using our function, let's evaluate the value of this. Let's say expression equals to this, and call this function. Let's say result, print result. Oops. Oh, you realize this error? What did we do wrong here? Okay, how should I fix it? Or I can do it only once. Or right?
Yes.
So I'm making sure that those numbers are integers. Okay, it works. So is this clear, everyone? We use the stacks to compute these postfix expressions. I'm not convinced it's clear. Okay, so what we actually did is first split the string, so we have this list, and then we iterate through all the items in the list. So if it is not plus or star, we kept pushing them to our stack. So if it is a plus, we pop from our stack, we pop two numbers from our stack, and then perform the evaluation. If it is plus, then push the result back to the stack. And same thing for star, just for multiplication. And finally, we should have only one value in our stack, and we just say stack.pop. Okay? All right, so let's move to another data structure, queues. So this is something we have in real life too. So it's can be a line of customers waiting for a service of some kind. So yes, usually the first customer in line is the next customer to be served. But there are some exceptions, like airports. At airports, customers whose flights are leaving soon are sometimes taken from the middle of the queue. Or at supermarkets, a polite customer might let someone with only a few items go first. Or if you are some shopping mall where you are like VIP customer, they might give you priority, etc. So the rule that determines who goes next is called queuing policy. So the simplest queuing policy is called FIFO, first in, first out. So whoever gets into the line first should get out first too. And the most general queuing policy is priority queuing, so in which each customer is assigned a priority, and the customer with the highest priority goes first, regardless of the order of arrival. Okay, so let's say you are a gold member of some like airline company, and then you might be given priority to get into the plane first. Okay. So this is how we can illustrate. So let's say this is the front. So we keep pushing from the back. Let's say we are not using priority. This is like first in, first out. So we keep, this is the front of the line. And whoever comes to the end of the line. And when we pop or when we remove item, we remove from the front. Okay? So first in, whoever got in first out, gets out first. All right, so implement class queue that has attributes length and height, where the initial values are 0 and none respectively. So let's say object, let's take, yeah, it doesn't take any arguments. So I'm gonna say init dot length is 0 and head is none. Okay. So add a method is empty to the class queue that returns true if the queue is empty. So this is easy too, right? So I just have this is empty self return if self length is 0. Okay. Now, add a method insert to the class Q that adds a new item to the queue. So remember, we are adding items to the back. And the method takes data as an argument. So I take all this. I say insert or you can say data. Okay, so are we using nodes or lists here? Let me see. Okay, so we are using nodes. So imagine each of these items is a node that we describe. So what should I do here? Create a node? Yes. Node data, right? And what else? So I have this self head. So first of all, if self head is none, I can just I can make self head equals node. Else, I need to find the back of the line, right? So how do I do that? So I need to insert this new node to the end. Okay, so let's define last as self head. And if last is not none, I should keep going, right? And finally, I find the last node, so I can just say that last node points to this new node we just have.
We have a master in node called add first. Can we directly use add first here? Then when we write in the method called eq, it's the number out of the queue.
Can you make what? The last?
If we make a method insert here, we still need to make a method output something. Use the algorithm.
No, we don't need it to output anything. We're just inserting.
Yeah. So in making this method, I think can we directly use the add first because we have write it in the node class.
Right, but it was for.
Yeah, we just add first, so every node will push to the back. It's like a queue. Then the output from the back.
But
that's also
with that we were adding to the front. Here I want to add it to the back.
But we are making a queue. We can add from first, then output from end.
Yeah. Oh, yes. Okay. Yes, you can do. So one of these, either when you do that, either insert or remove, have to find last or front.
Yeah, but if my mean is, I make an insert here, I need to find the last. But here we just use the original method.
Okay.
We just need to use the on one time.
Okay. Yes, we are gonna talk about that too. But when we do that way, yes, insert will be easy, but remove will still be linear time.
Yeah, but if we write insert because we don't have a remove first in node class, right? So if we use node,
Yeah.
every method is linear.
So we are going to talk about it. We are going to find a way where it is constant time. But with your logic, either insert or remove has to be linear anyway.
Yeah.
So in this implementation, I'm using this way. So insert is going to be linear time. Yes, we have to find the last item in our queue in order to insert a new item. Okay. And also, we shouldn't forget the length, right? We should increase that too. So is this clear to everyone what we are doing here? So we are actually trying to get to the last. And once we have this last node, we just point it to the new node that we just created here. And of course, we also increase the length by 1. Wait, it should be actually next. Yes, so if last dot next is none, we are actually at the last node. That's why it should be last dot next. And then since last dot next is none, we are actually changing it with the node. Okay, so we have the insert, and now we need to add a method remove to the class queue that removes item from the queue and returns the value of that item. So remove is going to be easy, right? Let's say remove. Any idea? Let's first get the data of head, because we want to return it. Data. Right. Oh, and also we need to remove the length. Decrease the length by 1. Okay. I want to so let's test this. So I'm gonna define q dot add let's say 1, 2, 3, 4, and also while let's print all this while q dot length is not equal to 0, or kind of I'm checking if it is empty or not. Print q dot remove. So what should it print? So this is a queue. I'm adding 1, 2, 3, 4, and then when I remove, this is first in, first out. It has to be either 1, 2, 3, 4 or 4, 3, 2, 1, right? Oh, insert, yes, yes, yes. Okay, so when we remove, so this is a queue. Person 1 comes first, second comes second, third comes third. So when I remove, first should go first too, right? So it should be 1, 2, 3, 4. Yeah. So okay, we just tested that our queue class works. All right, so here is the performance characteristic, like what we were just discussing. So, okay, so remove is good because there are no loops or function calls here. So it means that the runtime of this method is same every time. So such a method is called constant time. So here remove, you know, we don't need to iterate over anything. So it's just a constant time operation. But for the insert, we have to traverse the list to find the last element, and this traversal time takes time proportional to the length of the list. So we call the runtime for this is called linear time. So compared to constant time, of course, this is very bad because here we need to go all the way to the end to insert a node. So this is not good. So we should do something about it. So implement a class improved queue that can perform all operations in constant time. So let's call this any ideas? So what did we have for queue? We had this. Any ideas? Exactly. Yes. So, I mean, we define self head. Why don't we also define tail, right? And now when we insert, we just move the tail and just add it to the tail. So for this, let's call this insert function, and it should also take a value data. So node is node data. So if self head, if actually not self head, we can make both head and tail equal to node. Otherwise, we make self tail dot next node and self tail node, and of course we increment the length. Oh. Okay, so see, now with my insert, I don't really need to go all the way to the end. I made it constant time by just defining another attribute here. So remove is going to be pretty similar anyway. Okay, so it's going to be almost the same as this one. except that if, so let's say after we remove the length is 0, in that case we need to update tail too. So if self length is 0, we will make self tail none. And of course we need to return data. Okay, so the only difference from the original queue is that I added this, so in case we removed all the items but we didn't update the tail, so we need to update tail if length is 0. Is this clear? We can test this by using this too. This should be improved queue. Oops, you made a mistake. Oh, I didn't run this. All right, so of course it's gonna output the same thing, but now this is better with the insert by just defining an extra variable tail. Okay. Okay. So now let's create a class priority queue. So far we just assumed that it was first in first out. We didn't really check the priorities. So now we are gonna work with the priority queues. So let's first define the class for that. Okay, so we are using actually lists now, so we don't need to worry about, let's not worry about nodes. So we initialize it as an attribute, a Python list. What should we call that attribute? Let's say items. Okay, and then so let's define is empty method that just returns length of self items equals 0, and we are going to have insert method insert self. So let's say it takes a data or item. So I'm gonna add it to the end. So I'll say self items append item. Okay, so far so good. So remove methods, add a remove method to priority queue. So this is going to be, so let's say the value of the item defines the priority. So if it is larger, it has larger value, then we remove it first. Okay. So when we work with numbers, of course, it's gonna remove the numbers that are larger first. Or if it is strings, it's gonna go through alphabetical order. So let's define all this and define a remove method. Okay. So now this is a little bit tricky, right? Any ideas? Okay. Biggest value, right? Yes. Okay, so let's call this max index. Let's say the first is the first item is the largest value, has the largest value, and then I go through for I in range. Let's say let's start from 1 because I already have 0 here, and goes all the way for the length of the items. So if self items I is greater than self items maximum index, then I'm going to make index I, right? And now I need to remove that item. So let's call that item at that index, max index. And now so now I find that item, but I also want to remove it. So let's say self items max index to max index plus 1, basically just one value. So I'm making it empty. I guess that's it. And return item.
You need to set the max index as the first one in items, because if all number is negative, negative.
But it's the index only.
It's the index.
Yeah, so I'm only checking. So I'm assuming the first item is the largest. Okay, so demonstrate how it works. So I'm gonna create a queue. Queue which is priority queue. And let's say queue insert, I don't know, 11, 12, 14, 13. So while not queue is, it doesn't autocomplete. While queue is not empty, let's say print queue.remove. Okay, so what do you think this is going to print? So we insert all this. So since 14 has the largest value, it should be removed first, right? And then later it should be 13, 12, and 11. Right? Okay, it works. Is this clear? Okay, now let's move to another class called golfer. That takes name and score. and creates attributes for those. So name is equal to name, score. So who knows how to play golf? Okay, so is less better in golf? Okay, so we need to define, we need to change our prior to structure now then, right? Less is more in golf. Just know, you just need to know that one. Okay, so okay, we implemented the class, and then it says okay, override print function so that it prints like Tiger Woods, which is the name of the person, and with the score. So let's override print by just defining this function, and then we say return, right? What should we call it? So apparently when you do this, it actually creates 16 characters for what you want. So that will be the name of the person and the score. So I'll say self.name, self.score. What did I do wrong here? Oh, it's invalid syntax. Oh, what is wrong? Oh, I don't. Sorry. Okay. All right, it works. So now let's test it. Let's define instance called Tiger. So golfer that we say, let's say Tiger Woods, where the score is 61, and print Tiger. Okay, it works. See, this 16 actually is just to create 16 characters here. Alright, so now override comparison functions for golfer objects so that smaller score is more. If you remember from last week, we redefined less than, greater than, or equal to. So we are gonna redefine what greater or less than or equal to mean for this object. So I take everything here. So let's say, let's start with greater than. It's gonna have self, and also remember, it also should take another object. I'm gonna call that other. Okay. So if self score is less than other dot score, I'm going to say return true. It's a little bit counterintuitive, but I want to tell my program that if score is greater than, if my score is greater than someone else's, I'm actually better. So I'm saying I'm redefining greater than. Otherwise, return false. And we can redefine the less than. Oops, sorry. This. And I'm gonna define equality to 2. Okay. Okay. So now I know if score is less, it is better. So now let's test the prior to Q with golfer class. So let's first define 3 players. I'm gonna call them again Tiger, golfer, Tiger Woods with score 61, and another one, Phil, again golfer. Let's give it a name, Phil. Oh, Phil Mickelson, 72, and let's define another one, golfer. This one, it's going to be 69. And I'm going to create a priority queue, exactly like what we defined here. And I'm going to insert Tiger, insert Phil, PQ, insert Hall, and while PQ not is empty, I'm going to remove. Okay, so what do you think we should print now? So who is winning? Tiger is winning, right? It is lower score. So it should be removed first. And Hall should be removed second, and this should be removed last. Because Tiger has priority. Because we redefined what greater than means for this object, and since our priority queue is working on these golfer objects, now it has a different meaning for greater than. Okay, so we got the right answer. Okay, so let's stop here. Next week we will continue with the trees. Okay? So see you next week. Oh, where is it?